Today is 7th October and our topic is solid state welding. It's very interesting topic, very interesting subject because we do not melt the material here. This is not a fusion welding. This is a solid state welding. That means two metals we will join, but we will not fuse them. We will not melt them. The welding will occur below their melting point by application of pressure, by means of application of explosion, by application of friction. Okay, so the main point here there will be contact, and on that contact there will be either rubbing or sudden pressure will be applied. Because of that, heat will produce on the contact surface, and that heat is not sufficient to melt the metal, but the material will soften up a little bit, and the high temperature will produce but will not reach the melt temperature. And that scenario, they get pressed one with upon other. So these two contact surfaces when get pressed, and on solidification, on cooling, basically not solidification, on cooling, the joint is being produced. Okay, so now the definition says the joining will be on solid state. This seems very interesting to me because you will find this fun. There are no extra shielding required, no welding helmet required. Okay, very less safety to be taken, and that's why the welding becomes much popular. No fume gases, no flashes comes out, no fire hazard. Okay, that's why it is also called green welding. So the joint is produced by the heat and application of pressure, and the heat is produced by rubbing or by applying hammering action. Okay, so we have to point out few points. The material does not melt. Number two, uh, heat and pressure is applied. Heat is produced by either rubbing or hammering application. Now, these uh, solid state welding are several types. First one is friction welding. Second one is ultrasonic welding. Diffusion welding, explosive welding. Let me check the syllabus if all types are in your syllabus or not. Let me check out. Or it will take 5 minutes. I will give you a overview if it is not in syllabus. Friction welding is there. Friction stir welding is there. Diffusion welding is also there. Okay. Okay, this is, the syllabus is not pointed out. It is given as a just solid state welding. So that means we can cover all the things, but I will give you idea and I will send out notes and I will show you videos also so that you can able to understand. Now let us start with friction welding here. So we will start with friction welding process. In friction welding process, it is also known as FRW, friction welding. Okay, solid state process in which two workpieces who are faced each other. One is rotating or moving related to the other one, so that the rubbing option happens, and because of the friction, heat gets generated. First, let me show you the working principle, how this works. Suppose we have two bars. We have two bars, and one is rotating, other one is fixed. Now, this rotating one is rotating, and pressure is applied in a mild way so that they can face each other. So pressure is mild pressure. Why mild pressure? Because when the pressure is mild between this contact surface, the rust or surface impurities, they get burnt. That is called burnishing operation. Okay, you need to remember this term, burnishing operation. So the rust and other surface impurities, dust and all, is get burnt in the if there is any paint, if there is any impurities, any type of uh, environmental degradation occurs, so those things get burnt. If there is any fungus, they all will get burnt because of the heat produced here. Now then the pressure get increased, the pressure get increased. One is rotating, this is rotating, this is uh, fixed. So now here, because of the rubbing, heat generates, and this surface, this contact surface, starts to become red hot, and after that it glows. When it becomes red, then it goes to the whitish yellowish in color, and it almost glows in a very bright fumes. In that time, we stop this rotation and apply more pressure. When the material in this joint region gets softened up, so a shape like this will occur. So then we stop the rotation and we compress them with more force, and as a result, this joint here get produced. And when we take out it from the holding sections, a joint like this get produced. So the sequences are like, this is 1, this is 2, this is 3, this is 4, this is 5. Now finally, these 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 sections, this flash which has been made because of the joint, as machined and get a cleaned surface. Either it get machined or get grind. so that we can get a good shiny surface. Okay, so these are the basic steps. Is the working principle clear? Okay, I'm giving a very small overview again. The component to be joined are first prepared to have smooth square cut surfaces. These surfaces must be smooth and square cut. Suppose the surface is like this, then joint will not be produced. You need to square cut it, and you need to face these two sides. One piece is held stationary while other is mounted in a motor driven chuck or collet and rotated against it with high speed. A low contact pressure may be applied initially to permit cleaning of the surfaces by a burnishing action. This pressure is then increased, and contacting friction quickly generates enough heat to raise the abutting surface to the welding temperature. As soon as this temperature reached, the rotation is stopped and the pressure is maintained and increased to complete the weld. The softened material is squeezed out to form a flash. A forged structure is formed in the joint. If desired, the flash can be removed by subsequent machining action or grinding action. The friction welding has been used to join steel bars up to 100 mm in diameter and tubes of up to outer diameter up to 100 mm. Okay, so 100 diameters can be joined, 100 diameter. Now the inertia welding is similar. This is the friction welding. In inertia welding, we use a flywheel. When we rotate this job, when we are rotating this job, we use flywheel. So here, this job is directly mounted on the chuck, and in inertia welding, the chuck is bigger and itself acts as a flywheel. And I will show a video on this inertia welding also. Now, this inertia welding is a modified form of friction welding, where the moving piece is attached to a rotating flywheel. The flywheel is brought to a specified rotational speed and then separated from the driving motor. So when we get sufficient speed, we separate the flywheel from the driving motor, and the flywheel automatically stops. We do not need to apply brake to stop the flywheel, because after achieving some speed, the driving motor gets detached by means of a clutch with the driving motor. So driving motor and the um, this flywheel, they're attached with the clutch. So when you disengage the clutch, the flywheel gets detached with the driving motor, and the flywheel stops due to the friction. Now the rotating assembly is then pressed against the stationary member, and the kinetic energy of the flywheel is converted into the frictional heat. The weld is formed when the flywheel stops its motion and pieces remained pressed together. Since the condition of the inertia welding are easily duplicated, the welds of consistent quality can be produced and the process can be easily automated. The heat affected zones are usually narrow because we do not melting the material, we are just making the object little softer. So that's why the heat affected zones are usually narrow, and since the time period is very short for heating and cooling, the radial and orbital frictional welding that we will see in our video. Now first we will check out the video, and then we will learn about it uh, or in a more advanced manner, like the advantages, limitations, applications we need to learn. But before that, we need to check out a video. So what we have learned in the copy, we need to check it in a real action. Okay, so give me some time, allow me some time so that I can measure them. Okay, I think this is the one. Okay, so this is the one. These are the two bars, and this is a simple lathe. You can see this is a lathe chuck, three-jaw chuck, self-centered chuck. I hope you remember. And this is just another attachment, small drill chuck, which is attached at the tailstock tailstock assembly. So now they are fixing it, facing one a bar to another. These are the tightening bolts. Very rigid setup is required. So next year when the college opens, I'll try to put this in your second year workshop lab or fourth year workshop lab. I mean fourth year machine tools and machining principal lab. So this is what is happening. Let me discuss it first. This is what is happening is the chuck is rotating and the tailstock, this other workpiece is fixed. So now the friction, the rubbing started because the wheel is rotated. Now let us advance. What happens? You see, this is getting heated up. The burnishing operation is occurring. You see the burnishing occurring and the surface impurities got burned up. Now see the heat is getting generated. When sufficient heat is got generated, then the chuck will stop. See the chuck stopped. Now pressure is applied and the flash is being produced. Now there is slipping between it, so that's why the joint is not proper. If there is any slipping, then it will not be good. Now you see, this is the joint produced. Now extra finishing operations are required. This is a machining operation to finish it up. You see how good the joint is. Now you see the joint you cannot understand when there was a joint. See, now you finish it up. See, there is no trace of joint there. A very small trace is there, but how good the joint is. These are two bolts having their heads as butt joints with a very simple setup. But their, you know, their temperature, their melting temperature is so high, it becomes very difficult to weld steels. See, this is done. Okay, so is the process, I think, clear now to everyone? Now do you need to discuss
Yes,
anything?
sir.
Okay, okay. So then
Sir,
now,
which type of material is used?
huh? I can't hear you,
Which
please.
type of materials are used?
তোমার বোধহয় মাইকটা একটু
Sir,
হ্যাঁ বলো।
sir, which type of materials are used?
The we'll discuss actually.
Okay.
uh, if the material is forgeable, then you can do the friction welding. At least one material has the must be ductile when hot. So if the material can be forged, then the material can be friction welded. Non-forgeable material cannot be welded. So you can use different materials, but different setup is required, because the material which are having with high melting point, they will require much more rubbing, much more pressure. But you can easily weld aluminium or mild steel. Okay, now let us discuss the advantages. So advantages of friction welding. Advantages are no filler, no filler material, flux, or shielding glass. Shielding gas is required. Number two, it's environmental friendly, environment friendly, no smoke, fumes, or gases. No material is melted, so narrow heat affected zone. Number four, the oxides can be removed easily. Oxides are very less, and oxides can be removed easily. Number five, this weld strength is stronger than the weaker of the two material being joined. So if there are two material, one is weak, another one is strong, different type of materials, or same material with a different property, the weld strength will be stronger than the weakest of these two joint parent materials. Okay. The next one is the easily automated for mass production. The process is efficient and rapid welds are made. Rapid means it takes very less time, and these plant requirements are minimum. And variety of materials can be joined. Lots of advantages, but there are very much limitations too. We'll discuss them too. Limitation: of friction welding? Only round bars or tubes which are capable to rotate about own axis, those can be joined. Non-forging or non-forgeable materials cannot be joined. Number 3, preparation and alignment of bars is critical for developing uniform rubbing. So capital equipment, capital of equipment and tooling are high. And
Sir, third point
yes,
target বোঝাতে
কোনটা কোনটা?
third point, sir.
Third point, preparation and alignment of the bars is critical for developing uniform rubbing. So suppose you are making a bar joint like this. So if you cannot align them properly, because this will be under heavy pressure and under heavy rubbing, so if it vibrates like this one job, then the joint will not be produced. And if the alignment is at an angle, if you see it at an angle, then also the joint will not be produced. They must be kept, face to face, and this should be aligned throughout the process. Otherwise the joint will not be occurring.
Sir, but then can't offset joints be made by this method then?
Offset joints, you mean at some angle?
Or like not aligned?
This type,
Yes, sir. Yes, sir.
this
Yes,
type
sir.
is this type joints are possible, of course possible. You turn one job, rubbing occurs, the material gets heated, now you stop it, and then you must have a mechanism so that you can apply pressure like this, okay, at a perpendicular axis, then you can do it. So with this other device, you must apply pressure so that this joint get enough pressure to get joint, and then you can join it, which is very difficult. But if you apply a grip like this is possible. Like when we apply hubs in your axle, so the hub is like this, and these axle end are like this. So when this rotates, these rubs, the heat is getting generated on the outside of the hub, sorry, in the inside of the hub and outside of the axle shaft. So when it gets heated, the pressure is applied and rotation stops, and this is the way these type of joints are produced. Okay, so I'll show you a video how the axles are being joined. This is a very, pretty much good application. Before you get into more application, let us see this. Just a second. Yeah, got it. What I am going to show is a made by a Chinese company. This is the machine. There are two ends, and this is the okay. This is the chart. I hope you can understand what this is. This is the hub. This is the actual shaft, and inside this the differential gears are placed. So there are two hubs, one this side, another one this side. These are getting aligned. You see here and here. There are two hubs to be attached with this axle. Now see the rotation already started in two ends. I think rotation started. Okay. See at a closer look. If you can remember, these two joints were not solid. These are tubes. Now rotation stopped. Rotation stopped and pressed. Again pressed with more pressure. See, the joint is being made. Now they shear off the flashes. See, this is the joint produced. Another example. These are the examples. Information. Chart. Okay. Okay. So this is the way in automobile industry these hubs are get attached with the axle shafts. This is so interesting, na? Applications. Aerospace engineering, agricultural, automotive, defense, marine, and oil industries. Aircraft, engine components, automotive parts like gears, engine valves, axle tubes, driveline components, shock absorbers, aluminium, copper joints in electrical industry, water pump components. Lots of uses are there. These are the main focused usages. Now I'll take 2 to 3 minutes to discuss the friction stir welding, which is very similar with friction welding. I will just give you overview today. I will show you a video today, and next day we'll discuss details on it. Okay. Okay. Today we will not see the friction welding because we need to see the inertia welding. I forgot to show you the inertia welding. This is also very important. What is actually inertia welding? If you remember, in case of friction welding, one object is rotated with uh, driving motor system with chuck. Here the chuck is replaced by a flywheel. Similar process. This is inertia friction welder for aerospace. This is the one object. This is the other object. This is the machine, and the left there is a flywheel. The chuck is replaced by a flywheel. Initially, driving motor rotates the flywheel, and then it get disconnected. This is called inertia welding. On the left, this is a flywheel. Initially, the highest pressure is not applied. Initially, very low contact pressure is applied to burn off the impurities on the surface. Now the final pressure is applied. Now you see the flywheel is disconnected. It slows down. Slowly it slows down. Stopped. Now more pressure is given. You wait for its cooling. The process is automated, that you can understand. But initial cost is high. Accuracy is good and very rapid welding process. Okay. Okay. So today we'll stop here.